The most common question which comes in our mind is how to select the book and how to get the proper beginning of the subject. There will be various authors present for the same subject and we have to choose our subject, author or book. There are always plenty of books written by various authors on any given subject. Concepts are same. These same concepts are explained by various authors in different ways. It is advisable to read views of various books because sometimes we understand one concept from one book and another from other. While learning, we shall refer the SWAYAM and other online resources along with reading the textbooks. It will give better understanding of subject. While preparing a subject, we shall create a mind map, study, and then teach someone else what we have learned from various sources. In this course, I am using the method of visualization of the information using our imagination. Let us now check out from which topic this subject is preferred to begin with by various authors. Most of the books written on electromagnetics begin with the basics of vectors and coordinate systems. But what may be the reason to begin this subject with the understanding of vector analysis and coordinate systems? It is said that well begin is half done. We can communicate from one location to another location by using smartphones. But have you ever wondered how it happens? Circuit and antenna part ends at the mobile phone. What happens next is the communication of these electric and magnetic field vectors in space. You may call your friend next door or any foreign location. These signals travel in the form of electromagnetic fields, and these electromagnetic fields consist of electric and magnetic field vectors. This makes study of vectors and coordinate systems very important. We are simply talking about the traveling of these field vectors in space, which is explained by coordinate systems, so that the journey of this subject will become interesting and easy. Hello everyone, welcome to today's session. Let us enter today's digital classroom. Everything is filled up with the waves, either sound or light. Hello students, welcome to this fresh course on electromagnetic fields. I hope everyone is doing well at home and following COVID-19 protocols properly. We are going to discuss about electromagnetic fields. This subject is considered as one of the toughest subjects. There are two types of waves. One is longitudinal wave and another one is transverse wave. Let us discuss about longitudinal wave. These are sound waves. We get sound from many objects. Even when we talk, we get sound out of our mouth. There are a few interesting facts about the sound. Sound travels 4.3 times faster in water than air. It has a speed of 1482 meters per second. Sound travels 3 times faster through steel material, and its speed is almost 4500 meters per second. Leonardo da Vinci was the famous Italian thinker and artist, and usually he is credited with the discovery that sound moves in waves. These sound waves in air are longitudinal in nature. That means the particles which are moving through medium are in parallel to the direction of propagation. A vibrating string can be an example of longitudinal wave. These sounds can be used in many functions, like sound can make objects levitate, sound can create electricity, sound can be used in medicine as ultrasound, sound can clean, sound can cure cancer. And acoustics is a branch of physics that deals with the study of mechanical waves in gases, liquids and solids, including topics such as vibration, sound, ultrasound and infrasound. Now, what are these ranges of the sound? We can divide these sounds into two types. Sound is a form of energy that is produced by vibrating bodies. But the question is, can we hear the sound of every vibrating body? The answer is no. So, according to our audibility, we can divide sound into two categories. One is audible sound and another one is inaudible sound. Human ear cannot detect sound frequencies less than 20 Hz. What is Hertz? Hertz is unit of frequency. And what is frequency? It is the number of vibrations completed in 1 second. That means we cannot hear the sounds which are vibrating less than 20 in 1 second. So to get it audible, the sound wave must be vibrating beyond 20. The maximum frequency human ear can detect is 20,000 vibrations per second, that is 20 kHz. Our ears can detect only a relatively small range of frequencies of vibration. Beyond what we can hear, there is infrasound, where the rate of vibration is too low for us to hear. It is normally below the 20 Hz limit, and there are sounds which are above our capacity of listening, that is 20 kHz. They are called as ultrasounds, where the rate of vibration is too high for us to hear. But few animals can hear these sounds. Like we can see here that dolphins and bats can hear the ultrasounds. Some animals like dogs have the ability to hear sounds having frequencies higher than 20 kHz. For everything there is a particular frequency. It is also said that human body parts are also having particular frequency. Another type of waves are transverse wave. We are concerned about the transverse waves. The examples of transverse waves include the motion of water on the surface. We might have seen the waves on the ocean, or the movement on the surface of water when we drop a stone on a silent pond. These are the motions which are perpendicular to the direction of propagation. We are concerned about the electromagnetic waves, which are nothing but transverse wave motion. A sinusoidal wave is an example of transfer motion. Here we can see that the direction of propagation is shown with this arrow, which is going towards the right side. And the sine wave, which is going up and down, is making a movement which is looking like the waves on a water surface. These are going upward and downward, which is perpendicular to the direction of propagation. Similarly, we can see horizontal movement. The horizontal movement is the motion like a snake. When a snake moves on a surface, we can see this kind of pattern. So the interesting thing is that the motion of electromagnetic wave will have the vertical and horizontal movement which is perpendicular to the direction of propagation. What we have to remember is that we have two types of waves. One is longitudinal wave, another one is transverse wave. The simple thing is that longitudinal wave are the sound waves. Transverse waves are the light waves. In sound, there are sounds which we can hear. Those are audible sounds. Its range is 20 Hz to 20 kHz. And there are inaudible sounds. These are below 20 Hz and above 20 kHz. These are audible to few animals. We have to remember that transverse wave is nothing but light. In light, we may have visible light or invisible light. Simply we have to remember that for sound, technical word is longitudinal wave, and for light, technical term is transverse wave. Now let us discuss few more details about electromagnetics and why to study them. There are many advantages of electromagnetic energy. It is clean, it is not polluting like oil and coal, nor it destroys the environment. All the waves, either sound or light, they carry some kind of energy from one place to another place. Light carries information in ways you may not realize it. Cell phones use light to send and receive call and messages. This invisible light we call as electromagnetic field or electromagnetic radiations. Wireless routers are light to send pictures of the images we use on internet. The radios use light to receive music from nearby radio stations. Even in nature, light carries many kind of information. We use telescopes. These are light collectors, and everything we know from Hubble is because of light. Hubble is a space telescope which can view objects in more than just visible light, including ultraviolet, visible and infrared lights. These lights enable the astronomers to determine certain physical characteristics of objects present in the space. There are many applications of electromagnetics, but the most important application which is concerned to us is in communication. Earlier there were telephones. Those were called as landlines. Those were not mobile. But after invention in the usage of electromagnetics, we have mobile phones. And mobile phones is a very good enough reason for us to study about the electromagnetics. Because if we forget mobile phone at home for a single day, we feel like we are handicapped. It is now part of our life. It is like a body part for us. We cannot survive without mobile phones. How this mobile phone works? They work on the principle of electromagnetics. When we talk, we convert our signal into digital form inside the mobile phone. These mobile phones then convert these signals into the proper appropriate form, which are ready for the communication. Then these signals are transferred to the outside world using an antenna. Electromagnetic radiation is all around you. Don't worry, it is just an energy from light. Radiation travels in waves like an ocean. Some wavelengths are long, others are short. Other than mobile phone communication, electromagnetic radiations are used in various applications such as broadcasting of radios and television signals. They are used in cooking in the form of microwaves. They used to transmit heat from sun fires and radiators in the infrared region. We use visible light, which is nothing but electromagnetic, absorbed by the skin. They are used in the fluorescent tubes. X-rays we use to view inside the bones and find out the defects. Gamma rays are used in medicine for killing the cancer cells. There are many applications of electromagnetic radiation. We shall begin all the subjects with the meaning of that subject. If you study any topic, chapter or subject, we have to begin with the meaning of that topic. We are going to study about electromagnetic fields. So we must understand the meaning of electromagnetic field. Electromagnetic. It is combination of two words. One is electros. That means it is related to electric field. Another part is magnetic. That means it is related to magnetic field. Combinedly it is called as electromagnetic field. So what is field? Field may be any place where number of forces are working together for one task. For example, we are playing football or cricket match. In playground, we are concentrating on winning the match. There are 11 players. They are working to win that match, and all the forces are working together for one task. That is nothing but a field of playground. If we consider example of classroom can be considered as a field of knowledge, where number of students are applying their force to understand the concept, and teacher is applying his force to make them understand. So there is one source and there are many destinations, those who want to receive the knowledge. Similarly, electromagnetic field can be termed as a place where number of electric and magnetic forces are working together for a specific task. Electromagnetic waves are transverse in nature. So we will concentrate on transverse waves. Transverse waves are perpendicular to the direction of propagation. We have to remember that. And what are these transverse waves? It is a technical name for the light waves. So there may be visible light or there may be invisible light. What is invisible light? Like we have X-rays, infrared or microwave. These are invisible light waves, and all of them combinedly called as electromagnetic wave. And the spectrum which covers all these different types of wave. Before going to that, let us have the meaning of electromagnetic field, why we are going to study that, and what are the problems are associated with studying electromagnetic field. For that we have to classify the theories. In electronics or electrical engineering or physics, there are two types of theories explained. Either we use field theory or circuit theory. Circuit theory is simple. It is related with only parameters which are coming from voltage and current levels. We know that there are two types of currents. One is alternating current, which is changing with respect to time. This is our time graph. And the current which is constant with respect to time, it is called as direct current. We have direct current, we have alternating current, we have voltages related to those particular circuits. The study of voltage and current comes under the circuit theory. The subjects like electronic devices or digital logics, they deal with the circuit theory. But when we come out of the circuit, when we need to deal wirelessly with the world where wires are not connected, for example our mobile phone has no wires connected with another mobile phone, but still we are able to talk, still we are able to communicate. And when we transmit some signal, either it is text message or a call, then the mobile phone must transfer it into the field where voltage and current values must be converted into field parameters. So directly we are not going to deal with voltage and currents when our signal is out of mobile phone or when it is in space, when it is traveling across a particular situation or medium. In that case, we are concerned with the field theory. The subjects related with field theory includes electromagnetic fields, microwave engineering, radar systems, even some part of satellite communication. Wherever there is involvement of any part of electromagnetic spectrum, we have to understand the field theory. If you are a mobile phone user, if you are a user of various gadgets, wherever there are various kind of waves are involved, then this subject, these concepts are for you. So this is about the field theory. We are concerned about field theory in this subject. Then next we will discuss about the meaning of electromagnetic field. Before that, we will break the electromagnetic term. Electrostatic. When we talk about electrostatic, that means electro means related to electric field, and static means which is not moving, which is in rest. That means our system is not in motion. And second part of electromagnetic comes from magneto. Magnetostatic. Magneto means it is related with magnetic field which is not moving. So when we study electrostatic separately, magnetostatic separately, the combined knowledge will give us clear concept of electromagnetic. So to understand electromagnetic, we will first study the case where things are static, not moving. Once we understand the situation where static charges or particles are considered and we analyze them, we understand them, then we can easily turn to the moving objects. So we can move to the time domain. So by studying electrostatic and magnetostatic, we will understand electromagnetic waves. So electromagnetic, next part is field. In this case, when we talk about electromagnetic, that means there are electric field and magnetic field components and they are working together for one particular task. So electric field means the place where electric forces are working, and when there are number of forces working together, it will have a particular intensity. There are 4 fantastic alphabets which are related with this subject. When we say field theory is nothing but the field parameters. A field which is a 3-dimensional place. So what we have to remember about the waves? First thing, they are in fields. They work in a space. They are having a number of forces working together. Which forces? These 4 alphabets. Everyone must remember it forever. First is electric field intensity. That is given by capital E. The bar on or the cap on the head of E demonstrate that it is a vector. So they are vectors also. And where these vectors are working? These vectors are working in space. A space around us, a 3-dimensional place. So one parameter, capital E, is called as electric field intensity. Wherever there is intensity, there will be density. So electric flux density associated with electric field is given by capital D. As they are vectors, we are showing bar on the head of these alphabets. These 2 parameters, E and D, are associated with electric field. Similarly, there are magnetic field components. Magnetic field intensity, it is given by capital H, and its density is given by magnetic flux. Let's make it simple. All of us know that light is an electromagnetic wave. Visible light, it's all around us. Now when you talk about light, it is present around us. Is the intensity of light same at all the places and all the times? No, it is not same. If you are in a room, there may be more light around the window. There may be more light near to the light source, bulbs or the tube lights. Wherever there is intensity, there will be this density associated with that. Intensity and density are directly proportional to each other. For every parameter, we will have intensity and density. We are concerned with E and D for electrical. We are concerned with H and B for magnetic field. These intensities are also called as strengths. So capital E can be referred as electric field strength. H can be referred as magnetic field strength. Capital D can be termed as the density. These are 2 densities. Now we will move to the parameters. One by one we will discuss these parameters. So we have discussed about field. So if we take an example, why we refer the example of mobile phone? Because usually we use mobile phones. So in all the communications, there will be one transmitter and one receiver. Someone is sending information and someone is receiving the information. So here we have one transmitter, one receiver. So the field is the place which is connected between the transmitter and receiver. This place, there is movement of electric and magnetic fields. This space, there is application of number of forces. Which forces? The electric field and magnetic field combinedly. So this is something defined as the field. We have to remember field, that our 4 parameters. E is electric field intensity, H is magnetic field intensity or strength. These are the parameters of field. Second, all of them are vectors. So what are the vectors? Vectors have both magnitude and direction. That means E. When we say there is E present in the space, that means it is a vector. It has direction and magnitude both. It will have a value. So we should be knowing the basic operations of vector. These are the prerequisites of the subject. What is meaning of prerequisite? Prerequisite means what is the basic knowledge we require from the previous classes to understand the concept of present subject. For example, we are studying electromagnetic fields now. So but we require some previous knowledge to understand the concepts of electromagnetic field clearly. So we know that they are vectors. So we must be aware of the properties of vectors that we will discuss in the next coming class. What are the vector parameters which we require to understand the electromagnetic fields? There are various properties. There may be vectors, combinations and subtractions in the space. So what happens if the two vectors are perpendicular, right? So second thing is that they are all operating in space. Suppose E is there, electric field intensity, it is a vector, and where it is working in space, 3 dimensions. What is our second prerequisite requirement? That we must know the knowledge of coordinate systems. Which coordinate system we require? We may require cylindrical coordinate system, the Cartesian coordinate system, or the spherical coordinate system. The knowledge of these systems is essential to understand the concepts of electromagnetic field, because our field parameters are operating in space, a 3D space, and that's what we call imagination. We require a lot of imagination to understand this subject easily. So this concept we have to understand. So various parameters of vector analysis, how vectors operate in space, and what are the different coordinate systems we will discuss in the next session. So what is in general the electromagnetic theory? Electromagnetic theory is a discipline of physics and engineering where we have to study the charges at rest and motion. So suppose this is the source, this may be the antenna, and it may be applying some force, and this particular ball is representing a single small charge. So first we'll understand the effect on a static charge that is not moving. It will come under electrostatic. So we'll study the principle of electromagnetic on a static charge, and then we will also study the effect on the moving object. So we have to study the charges at rest and in motion. That is part of our electromagnetic theory. So now let us move to the animation, and we will see what are other parameters required and what are the other invisible lights we are talking about involved in the spectrum. Our eyes see only visible light, the rainbow light, the waves which are found in the middle of the spectrum. With bare eyes, we can't see the other wavelengths on the spectrum. Those are termed as invisible light. But some animals and technologies can read those frequencies. For example, bees see ultraviolet light waves coming from the sun. And flowers have ultraviolet marking. Those are called as the pollen guides. Bees see a bullseye for nectar, but we can see just pretty pattern on the flower. It's all about light from heat for the mosquitoes. Mosquitoes can see in infrared, and they can very easily detect the warm blood. Radio waves have the longest waves on the spectrum. We are going to see about the spectrum shortly after this discussion, but those are so lengthy, sometimes one wave starts in one country and it completes one cycle in another country. Like that, there are many other applications. We require a proper gadget to access the invisible lights, what we are calling. Once you are in a classroom, there are so many different type of signals around us. There may be FM radio signals. If someone play FM radio, he can listen the songs. There may be news channels. There may be so many different internet stuff. There are so many signals around us, but can we hear them? Can we see pictures moving in the air? No, we cannot. There are thousands and thousands of the things moving in the space around us, across us. Someone is calling in the classroom and those signals may be passing across us. But we cannot detect signals like this. We require a proper gadget to access that particular frequency or that particular wavelength. If we have microwave, then only we can use it for the cooking, heating the food. We cannot access microwaves without any proper gadget. We require X-ray machine to see inside the human being. Each electromagnetic wave have two components. One is related to electric field and another one is related to magnetic field. Every electromagnetic field have a specific frequency. Let us discuss what is frequency and wavelength. These waves are sinusoidal wave. We can consider horizontal wave as electric field intensity and vertical wave as magnetic field intensity. Vertical wave as electric field intensity. It depends on the polarization that we will discuss in some other class. Now, every wave have its peak value. It's a alternating signal, continuously changing values with respect to time. Signal is passing in time from one place to another place. These two movements can be considered as ocean wave and the snake wave. The vertical waves which are moving up and down can be referred as ocean wave. And what is another wave? Another wave is moving on the ground, on the surface like a snake, on the horizontal plane. These two waves of electric and magnetic forms electromagnetic wave. From every angle it appears differently. Like we can see here in the front view, we can see only a plus sign. But in actual, in 3D shape, these are the two waves. From side view, we can see only vertical wave, say electric field intensity. From top view, we cannot see electric field intensity component. We can see only magnetic field intensity component. But when we see it from a particular proper angle, we can see that it is an 3D electromagnetic wave with two moments.